Okay, so we're revisiting problem number 19. This is the one that I said that was really far more difficult than the other problems around it in this test, where you had you were told the sum of the roots is -3 and the product of the roots is -9. Which equation meets these requirements? Pretty simple observation that, for whatever reason, eluded me. It basically goes like this. If you have a quadratic equation, x squared plus, and then its negative sum of the roots times x plus the product of the roots, right? That's basically what we're looking for. So the sum of the roots here is -3. So when we do -3, x plus the product of the roots is -9, right? Here's x squared. We have x squared plus this. This is just x squared plus 3x minus 9. Okay, so we kind of have this in equation number 1. We kind of sort of have it here. We have plus 3x, but it's plus 9, so we really can't do anything there. But if we just multiply this whole thing by 2, right, that doesn't change the roots of the equation. It'll just make, we'll have some parabola with roots there. When we multiply it by 2, it's, it's going to look like this. It's going to have the same roots at these 2 points. It's just going to shift the graph about a little bit. So anyway, if we do this, we result with 2x squared plus 6x minus 18, which is exactly the answer that I arrived at by a slightly more painful method. So the key thing to know is right here, that x squared plus the negative sum of the roots times x plus the product of the roots is the equation to know. Now, there's a reason behind this, and I want to go over the reason behind this, and it comes from the quadratic equation. So let's scroll down here and go back to the quadratic equation. All right, we know the quadratic equation says the roots of quadratic equation ax squared plus bx plus c equals 0 are precisely x equals -b plus minus the square root, and then all under the square root we have b squared minus 4ac, and then this entire thing is all divided by 2a. Okay, so that means we have one of these is plus square root b squared minus 4ac squared. The other one is minus square root b squared over 4ac on minus 4ac. So let me do a little bit of copy pasting here. So we have this. Oops. Okay, so we have this, and we want to copy it and paste it. Okay, so that's one. We're going to add these together, and then let's add to it the counterpart over here, right? So we're going to add these two things together. Oops, let's add them together. And one of them is going to be plus, so we'll get rid of that, right? And the other one is going to be minus, so we'll get rid of that. And this is pretty much what we're adding together. We have the same denominator, and we're going to have this whole part of this fraction cancel out with this, because one is plus and one is minus that term, so they cancel out entirely. Then we have the negative b and the negative b, so we have negative 2b over 2a, which equals exactly negative b over a. Okay, so that's the sum. That's the sum of the roots. Right? So this is the sum of the roots. Okay, the product of the roots is where we're going to multiply these guys together. We're going to take these and multiply them together in the product of the roots. So let me scroll down a little bit farther. Right? We'll keep that sum there for reference. So here's one part of it that we're going to multiply, and we're going to multiply it by the same thing. Only thing, again, remember, one of these is positive, one of these is negative, so this one will be our positive one, and we're going to multiply it by the negative one, right? And this is just some algebra here that we're doing with the quadratic equation. So now we're multiplying these together to get the product of the roots, and it's a difference of squares divided by, the 4a, what's going to turn into 4a squared, right? So we multiply these together. Let's put everything over 4a squared and then concentrate on the part that's going to go here, right? So we have negative b times negative b, right? That's the first term. We just did that. Then we're going to have some canceling happen here. We're going to have the plus b squared minus 4ac times negative b. That's going to cancel with this guy over here, which is going to be minus square root b squared minus 4ac times negative b. So we have the plus and we have the minus. They're going to cancel out. They're not even going to factor in. And then we are going to multiply this term times this term, which is going to be exactly, we're going to have a negative, and it's going to be b squared, I'll put that in parentheses, b squared minus 4ac, right? And it's all over 4a squared. We're just doing the top part of this. So we do a little bit of algebra here. This is going to be positive b squared minus b squared plus 4ac, right? Well, the plus b squared and the minus b squared cancel out, and we're left with just 4ac, which is what goes on top here, 4ac, right? Well, the 4's cancel out. This a cancels out here, and this turns into just regular a. And so we have the product of the roots. The product of the roots is going to equal c over a. Okay, so the product is equal to c over a. All right, so if you're still with me, we have the product is c over a. The sum is equal to negative b over a. And if you go back now to the original, a squared plus bx plus c, right? And we divide, I'm sorry, ax squared plus bx plus c. And we divide everything by a. We have x squared plus b over a, right, times x plus c over a. Okay, and now we notice that this is the product. That's the product of the roots. And this guy over here, this plus b over a, is equal to the opposite sign of the sum of the roots. So that's how we got that formula. Okay, this is the derivation of the formula. If you just remember that it's x squared plus, the negative of the sum of the roots times x plus the product of the roots, you're okay. But this is a way to derive it, and maybe I'll even go back and make a video that's more clear. But that's further into depth on that one problem.